So I think that we'll just start with the introduction. And, it's almost the hour. Don't want to miss any time. So hello everybody, and thank you for coming to my session. I am Maor Lipchuk. I work in Red Hat Israel in the oVirt storage team, and today I want to talk to you about the solution that we introduced in oVirt 4.2 of disaster recovery using Ansible. So we'll start with a really rhetorical question: can a disaster be avoided? Well, I know it's a stupid question, but when I Googled it, I figured out that really many big companies, well-known companies, encountered a disaster one way or another in their lifetime. And you can't really avoid any disaster. But what really makes people appreciate companies is how they recover from them, how they recover fast and efficiently without almost any data loss. So what about oVirt and disaster recovery? How do we support this? So through oVirt versions, we had several types of solution for backup and disaster recovery. I want to go over a few of them to get the notion of what we introduced in oVirt 4.2. So at the beginning, well, there was an export storage domain. This is basically a file storage domain that was used to back up VMs that the admin really cares about. It's a file storage domain that it's simply attached to a data center, copy the VMs or the templates that were carrying to him, that were imported to him, and once he wants them back, he simply copy them back to the setup. This is a great solution to back up VMs or templates, but it's not really a good solution to recover your entire data center. You can't really put your entire data center into one storage domain. Also, the copy operations are pretty heavy, and it will take him days to recover the entire data center. So in oVirt 3.5, we introduced some kind of a new solution, which basically is two features. It's the OVF store disk and the import storage domain. The OVF store disk is a special disk. Every storage domain basically contains it. It's managed mainly by the engine, and it contains the entire OVF of the VMs and the templates, which have disks on this storage domain, which are assigned on it. So basically, in OVF is an XML representation of this VM, and we can take this XML representation and represent it in the engine as a VM as itself, and also as an XML in the OVF. So this OVF store disk is being updated every configurable minutes, and all the data of those VMs and templates, all those configurations, are being held in this OVF store disk. So basically, if a user replicates the storage domain, he can use the storage domain, attach it to a data center. The engine reads this OVF store disk and can use those OVFs to basically recover all those VMs and templates. So the benefits of this technology is that there are no copy operations, and we can recover the entire data center now. It's much more easy. Every storage domain is basically self-contained, his kind of state, and it's more easy to make this type of recovery. But this is still not a full solution. The admin still need to orchestrate through all the solution. He needs to import those storage domains. He needs to register the VMs and the templates and pick the right clusters which are compatible with those VMs. He can make mistakes in the middle, and he probably needs to start all over again. And when we talk about recovery process, it will probably be after a disaster, and everything needs to be right now, and everything is really important. So we want to make it more automatic. Second thing is that the OVF is great and everything. We can see all the properties of the VMs, but there are still missing parts that needs to be filled in. For example, we don't have any notion of permissions of a VM. We don't have, for example, the cluster and a few other properties that are still missing from the OVF, so the admin needs to fill in them himself. So what is new in oVirt 4.2? So first of all, we were trying to fill in all the gaps. We were trying to see what we were missing. For example, external LAN disks, which are special disks which were not part of the OVF. Now we put them in the OVF. We also inserted permissions and VNIC profiles and cluster names and a lot of properties that I won't go to each one of them, but you get a point. It's much more easy for the admin now to recover and register those VM templates. Second of all, we added a new file in the OVF store that basically will contain some kind of extra data, some kind of extra data that is not really belong to the OVF. And one of those properties are the VM statuses. So now, every few times, we get some kind of a backup to the OVF store disk of all the VMs which were running before that. So when the admin wants to recover his data center, he can know which VMs ran before, and he can decide whether to run them again or not. The third thing is that we defined a way to support recovery of a setup that is basically that should be supported for disaster recovery, and it's called DR site to site. So what are the pre-requirements to make your setup ready for disaster recovery? So first of all, you need replication. You need to take the storage domains, which are important to you, and you need to take care of replication of them to another site, another server, another storage server that will keep them updated. Second thing, you need to prepare a just-in-case setup. You need to get a different setup and configure the cluster, the networks, the hosts, all besides the storage domains and the VMs and the templates. And the idea is that you will have some kind of just-in-case setup that will probably have slow storage domains or hosts, but it will run, and in case of a disaster, you will get recovered pretty fast until you will fix your primary setup, which is the more efficient one. The recovery process simply take the application storage domains, import them, and register the VMs and the templates, and run all the VMs which ran before. That's the idea behind it. But there is some kind of a problem. You have a different setup. You probably have different networks. You probably have different clusters. You probably have all different attributes. And as we said before, the OVF represents the VM. This OVF has a notion of a different cluster name, a different type of network, and you need to basically, theoretically, take the OVF and change all the data that is in it. Change the cluster, change the network name, change whatever it takes. Yeah. So the third step is prepare a mapping file. This mapping file will basically pre-configure all the mapping that needs to be done. If the VM ran before on cluster production, and now there is a disaster and we want to register it to the secondary site, now the cluster name is temporary cluster or test cluster, again, also with permissions and other properties that needs to be mapped. So theoretically, this is how it should look like. We get OVF, and we use this mapping that we apply on register, and theoretically, the OVF should now look like that. But writing mapping files could be exhausting. You need to go over the primary site. You need to basically write all the cluster names, all the data centers, everything that's been there and use it and then write the secondary mapping as well. So for that, we introduced oVirt Ansible disaster recovery role. oVirt Ansible disaster recovery is basically a role, an Ansible role. It is part of the Ansible Galaxy. It's part of oVirt Ansible repository. Basically, oVirt Ansible maintains multiple Ansible roles, which support all kinds of oVirt infrastructure operations that can be done on oVirt. So what oVirt Ansible disaster recovery provides us? First of all, it provides us an automation way to generate mapping. You already have the primary setup running. You don't need to go over all the entities and map them yourself. You can do it automatically now with oVirt Ansible disaster recovery. All what is left for you is just to fill in the secondary data, the mapping data. Second of all, it supports failover and failback, which I'm going to talk about in a few minutes. So let's talk a bit about how the mapping generator works. So basically, as I said before, you go over the entire primary setup and simply, in an automatic way, gives you a template of this mapping that you can use for registration in case of a disaster. When you want to use it, you simply need to define a play, that's about it. You need to put in the username, the password, the site, indicate that the role that you want to use is oVirt Ansible disaster recovery, and simply run this command. It's a forward command, nothing too fancy, nothing too complicated. You indicate that you want to use the tag generate mapping. You execute the DR oVirt setup YAML, which we showed now, and voila, you have a var file, an automation var file. And as you can see here, you need to fill in all the properties for the secondary site. So after we have the secondary sites already prepared, we have the mapping, and we have the replicated storage domain, we are ready for doomsday. So what happens now when there is a problem and there is a disaster and we want to fail over really quick? So as part of the oVirt Ansible disaster recovery, we have a role which is called the failover. Basically, it recovers the secondary setup automatically using the mapping var file. What automation is basically doing is that it first imports the master storage domains of all the data centers. Then it imports all the other storage domains. It registers the templates with the mapping which we pre-configured before, register the VMs, run first the highly available VMs because probably your secondary site might not have the same computed resources as the primary site. And then run all the other VMs. So for failover, to define a play, also as simple as it gets, simply need to have a target host, which is the secondary host. That's the host that we want to do the recovery to. And the primary source map, which is the mapping file to know when we get the VM, to know which attribute of OVF we should map from to. Again, simple command, and disaster recovery is basically done. I want to show you a demo, which is a 1-minute demo of how it basically works. So you can see here that before that we have a VM which we're running. This is the mapping file. On the top you will see immediately that on the top is the primary site. The secondary site is at the bottom. We configured here a role. We start the failover here. Here the Ansible is running. We start by importing the storage domains. So here at the top you can see the primary setup, which all storage domains are inactive. The secondary setup are being attached with all the storage domain. All this done automatically, nothing that the admin actually does. Once the storage domains are attached, we start by registering the templates and the VMs. You can see here the VMs. Here it is, one VM, second VM, and now it runs the VM which ran before on the primary setup, all automatically. And you can basically, okay, it's missed. So all those properties were basically met. Okay. Second. So once we did the recovery and the secondary site is up and running, now we want to fix the primary site probably because it is basically the production site. And once it is done, we want also a use case to return to the primary site as before. So there is a new, also an Ansible tag for that, which is Failback, which basically restore the primary site as it was before. The process here is that it basically cleans all the secondary site, detach all the storage domains, use the replication the other way around, and start the failover all over again, but on the primary site. So basically all the changes which was done on the secondary site are also being updated on the primary site itself. So what we see. So in oVirt 4.2, we basically fill in all the gaps of VMs and templates in the OVF, fill most of the gaps. VM statuses are now part of the OVF store, so we can know which VMs ran before the disaster, and the admin can choose what to do. The recovery process is automatically, thanks to Ansible. The admin doesn't have to break his head or use all kind of magic to do so. It makes it much more easy. And the user can choose to also failover and failback his environment whenever he wants to. Those are links to Ansible Galaxy of the role of disaster recovery. You can also share your patches there on GitHub as well. That's about it. Do you have any questions? Yeah.
Two. First one is, are there any plans to integrate the mapping and the failover into the user interface in oVirt engine so that you don't have to go and run playbooks out of Galaxy? And then the second question is there any plans for file-based replication so that you don't need to do hardware-based replication for like lower-end use cases?
I'm not sure that I really understand.
Agent-based replication at the hypervisor layer, so that you don't have to, you can actually solve that problem without using like SRDF or, hardware-based replication.
Well, let me first answer the first question. So the question was, So the question was, do we have any plans to make some kind of a GUI, right?
Yeah.
Some kind of a GUI using oVirt to manage the var file, the mapping file, right? Yeah. So there is a plan to do that. Yeah. First of all, we start with using it through Vim or any other file editor. But eventually we do have plan to make it managed by the GUI. Can you repeat your second question?
Oh, the replication. So today you don't handle replication, but is there anything planned in oVirt to handle the replication of the virtual machines so that you don't necessarily have to depend on hardware to do it, or use cluster or something along those lines?
Well, the thing is that, okay. So the question is whether we plan to support replication of VMs, you say?
Yeah,
Or well, VMs are basically XML. So
I guess a way in which you could do file-based replication from oVirt, so that you don't have to spend a lot of money with a storage vendor.
Yeah. Well.
Right, but that's not built into oVirt today, is it?
Well, the replication.
It doesn't matter what replication you have.
Right, but what I'm suggesting is it would be helpful to have to integrate the replication, the software-based replication, into the VR process.
Okay, well, I think that regarding the replication, for now we
use whatever.
we use the replication of the storage domain. Regarding files, I think you don't have. I think there are a few open source solutions to make some kind of. Yeah, that's how I tested it, by the way. But
I'm suggesting like it would be a really, from a usability standpoint, it'd be really cool to see that.
Okay. Yeah. You got a question? Sorry.
oVirt and Gluster do support it, but there's tooling around it that is the issue. It's like Gluster supports that use case already.
Okay. Yeah, but.
There need to be tooling around it, so and it need to be tested in QA, so we can trust it because VR is important.
So you need to use Gluster for it, right?
Yeah. Gluster supports it, but so it's like if you use Gluster as a software-defined network-based solution, then it's possible to use it in that use case, but you need to be QA, you need to be tested, and you need to be documented.
Oh, it's good to know. So, yeah. So basically, we do know that Gluster supports it. Okay. Any other questions? Someone? Maybe? Okay. Yes.
Can you give that previous slide, please?
Yeah.
Thank you for using Ansible and not writing something new.
Yeah. Okay. Someone.
This is what the potential ref customers ask all the time: is how do we do VR?
Yeah. No, this is awesome. Like, I mean, it's super exciting. I think the software replication, like, that's the one thing Site Recovery Manager does for people that don't want to spend a lot of money with asynchronous replication with like SRDF, is they give you like an agent-based way of doing hypervisor file copies, right? So if you get that, you basically
Feel free.
Take a look at the VMware solution with the site recovery manager. They also do not include the storage mirroring piece. This has to be done by.
It's separate, yeah. But actually, that'd be really easy for us with Gluster to solve.
Geo-replication.
Yeah. And then make it part of it, and you're actually a step ahead of them. Yeah.
Cool.
One more comment on the Gluster side.
Sure.
I really don't know almost tested that is. It's like I know it's all the Gluster slides and documentation and all that kind of stuff.
Yeah.
I know they have some ideas. I don't know how much customer usage of that use case.
Of this.
We actually do have several large customers using hyperconversion.
Well, I'm out of time. So sorry, but if you have any questions, please. הלך לדפוק את הראש.
So can you free up the space so the next speaker can get ready and also give